There's 3 free response questions on your test. I'm going to go through the third one. Please try all 3 questions on your exam. The third problem states, given the function g of x, what are the equations of the asymptotes of the function? Determine if there are any points of discontinuity. Explain why or why not. Describe the end behavior as x approaches negative infinity and as x approaches positive infinity. This is the last thing that we did this semester, so hopefully this will be fresh with you. So let's start with the vertical asymptotes. You're going to look at your denominator. Look at what values of your denominator will make this function undefined. So you have x plus 4, x minus 2, and x minus 6. If the factor only appears in the denominator, like x plus 4 and x minus 6, then you have a vertical asymptote at the value that will make them 0. So we have a vertical asymptote at x equals negative 4 and at x equals 6. For horizontal asymptotes, you have to look at your degree of your polynomial functions. So the degree of our numerator is 2. Degree of our denominator is 3. If the degree of the denominator is greater than the degree of the numerator, then your horizontal asymptote is at y equals 0. If the numerator degree is greater than the denominator degree, then you don't have a horizontal asymptote, you have a slant asymptote. And if it's the same, you would take the ratio of the coefficients of your 2 polynomial functions. So in this case, y equals 0. Okay? Second part says, determine if there are any points of discontinuity. We also call points of discontinuity holes or removable discontinuity. So in this case, it's when a factor appears in the numerator and the denominator. So in this case, we have x minus 2 in the numerator and the denominator. Therefore, there is a point of discontinuity, or what we call a hole, at x equals 2. Meaning the function is not continuous there. Okay? And last, it says describe the end behavior as x approaches negative infinity and as x approaches positive infinity. Alright? So, as x approaches negative infinity, what's going to happen to g of x? As x approaches positive infinity, what happens to g of x? So let's look at this. If I plug in a negative number into this function, you end up with a negative times a negative, right? If I plug in a negative number, let's say negative 1, it'll be negative 3. And negative 3 plus 2 is negative 1. So when you multiply that, that'll be a positive. Down the bottom here in the denominator, to plug in a negative number, it'll be a positive times a negative, which is also a positive. So as these numbers get bigger or go towards negative infinity, they're really getting smaller, but when you multiply, it's going to be bigger. Your g of x is going to approach 0. Same thing in the positive way. As x approaches positive infinity, g of x will approach 0. You can always check that by looking at your graph. So if you graph this function, if you want to multiply it out first and then graph it, you can do that, or you can put it in exactly like you see it. Just be careful with your parentheses. So when I graph this function, I'll zoom in on the calculator for you. You notice as x goes to negative infinity, the function approaches 0. As x goes to positive infinity, the point also approaches 0.